can give me number 1? Who has number 1 done? Yeah, Kevin, go ahead. Oh, that's not what I want. 120. There we go. Luke, you want to number 2? Yeah, very good. And 12. 3. Yeah, go ahead, Jenna. And number 4. Go ahead, Adam. 2,520. Last one, number 5, Gio? Yeah, awesome job, guys. 720. We're feeling good about that? Yeah? Alrighty. Let's move on. We're starting today with a vocab word. I shall move this. All right. Yes, this is a very important vocab word. Like I said, last week we talked about permutations. This week we have combinations. Combinations is a selection of R objects from a group of N objects. So it's the same variables there, R and N, right? N being the whole that you're taking from, and R being those arrangements that you want from all N objects. Where order is not important, that is probably the most important piece you can grab from this, that combinations, order doesn't matter, order is not important. In permutations, if you remember, we talked about how that's kind of like a locker combination. Order does matter. Combination, it's not important what order things are in. It just matters that those components are part of your answer. So another thing that is mentioned in this definition is that it is a subset or a smaller group of the number of permutations of N objects taken R ways. So we have a group of permutations, and within that is the group of combinations. A good way to remember combinations is like choosing. You're choosing from a group. It doesn't necessarily matter the order, you're just choosing. I also mentioned fruit salad. It doesn't matter what order you put the fruit in, just as fruit salad and delicious. So down here we have another formula that we should dedicate to memory. That is, now we have NCR instead of NPR. The formula for this is going to be N factorial over N minus R factorial times R factorial. It's a little bit different there with that R factorial on the bottom. Once again, I'm going to ask you to memorize this. It just helps with getting used to, what is this actually asking me? What is my calculator calculating when I ask it to do NCR? You probably saw this when you were using the NPR button. It was right near it. Math, scooch over to probability, and it is number 3. Number 3. We're okay? Alrighty. This next part is for your visual entertainment. This is important just to see with your eyes, how are permutations different than combinations? How do these two things differ from one another? So we're going to take another look at the word math. And this time we're looking for, oh my goodness, we're just looking at the 2-letter permutations in the word math. So I'm just going to list these out and you can just copy them right for what I have, just to make it go a little bit faster. I don't think it's necessary we need to brainstorm these. I know you could do it. Notice I'm taking 2 of the letters out of the word math and I'm writing them, then I'm just flipping them, right? Because order matters, so it's different when it's MA than as opposed to AM. So that's the 12 different 2-letter permutations for the letters in the word math. Can someone let me know how I would maybe set it up mathematically with my NPR equation. Claire? Do you know the? So I agree with the 4P2. Yeah, you're picking from the 4, you want just 2. Right, nice job. So from there, this is something that I would always want you to show in your work. 4 factorial over 4 minus 2 factorial. So that's 24 over 2, or 12. And that's what we got, right? We got 12 different permutations. That's just showing you that, this 4P2, works out when you actually do it with brute force. Over here we have the combinations. Now combinations, the order doesn't matter. MA is the same thing as AM, right? We have the same pieces, so we can only count MA, right? TA, HP, H, HM, and TM, right? We had to get rid of all of those ones that all we did was switch the two, because order doesn't matter, so it is the same thing. So down here, how would I set up that formula with my N and my R with the combination? So I need my C. What is my N and what is my R? I'm doing the same thing here, just using the math part. Yeah, it's just the 4 letters, and we want arrangements of 2. So now we get to put our new formula to use. 4 factorial over 4 minus 2 factorial times 2 factorial. That leads us to having 24 on the top again, and then that's 2 factorial over 2 factorial, which happens to be 4. So we have 6 different combinations. Just shows you, in the definition you wrote that combinations is a subset, smaller group. Well, yeah, this is a subset of this. It's a smaller group of the permutations there. Are we okay with that visual? I think that kind of helps to clarify what's the difference between a permutation and a combination there. We're good to move on. We have our first example here, applying our formula and our knowledge about N and R with combinations. So, we're in a bookstore. You're picking 8 books from a stack of 32. If the order of the books you choose is not important, that's like awesome. If they tell you that, you know for sure you're working with combinations, right? Because with combinations, order doesn't matter. So if the order of the books you choose is not important, how many different 8 book groups are possible? So the number of ways to choose 8 books from 32 is, let's establish our N and our R, all of the objects we're picking from, and what are the arrangements? Yeah, Kristen, N is 32, good. Someone else want to tell me what R is? What are the different arrangements? How many? Yeah, Megan. 8, yeah. So we'd set that up with 32, C8. Remember, in your bookwork tonight, you would definitely want to show you plugging these numbers into the equation. Yeah, Gio? Let me write out the whole. Make sure you have all this too, right? Okay. So we're just writing our N factorial, that's 32, and then N minus R, that's 32 minus 8. All right, ready for you, Gio? I would check with your calculator, make sure you got that. Take a moment to do that. Like I said, on your homeworks, I'd like to see this, and I'd like to see you plugging those numbers into the formula. But after that, don't feel like the need to, calculate all those pieces individually. You can definitely jump back and you know how to type that into your calculator. If you're not sure, you can just ask me and we can clarify that. Did we get what Gio got? Yeah? Nice. All right. So this is, yeah. Just make sure you get all the notes. He told me about his early dismissal. Not just like, yeah, peace out. So this example is pretty straightforward, right? This is a situation, just one scenario in this whole word problem. We're going to come across word problems where they say, well, I want this event to happen and this event to happen. Or I want this event to happen or this event to happen. You know, multiple things could be happening in one word problem. So we need to think about, well, what if that happens? What do we do in terms of our operations? So to multiply or add, that is the question. So we have to think, when finding the number of ways both event A and event B occur, we blank. And then we need to think about, when finding the number of ways that event A or event B can occur, we have to figure out where multiply and where add go. Does anyone have any ideas? I've had people throughout the day kind of guess, and we've gone with it. Either fixed it up if it was wrong, or yeah, Gio, what do you think? Yeah, you're correct. So whenever it says, I want event A and event B to happen, multiply. When you want event A or event B to happen, you need to add those combinations or permutations together. If you think about that first bullet point there, that kind of reminds me of the definition of our fundamental counting principle, right? If event A happens in so many ways and event B happens in so many ways, you multiply them together. That's what it's telling us. We want this and this to happen, so you multiply those together. I said another way, if you're having trouble remembering, this is the longer word, and that's the longer word. And is longer than or, multiply is longer than add. Just a silly way to remember it. Just thought I'd throw it out there. All right, so let's work with this. So we have to now work through this example where we decide whether we're multiplying or adding. So we're in a movie rental store. Those like don't exist anymore, but let's pretend. We have like cool things like Netflix now. But so anyway, in this movie rental store, they're having a special on new releases. The new releases consist of 12 comedies, 8 action, 7 drama, 5 suspense, and 9 family movies. So for part A, you want exactly 2 comedies and 3 family movies. How many different movie combinations can you rent? So we want exactly 2 comedies and 3 family movies. So that's key that you see this situation. We want this situation to happen where we get 2 comedies out of all of the comedies and 3 family movies out of all of the family movies they have to offer. So if we jump down here to the solution, part of A, you can choose 2 out of those 12. They told us up here, 12 comedies. So we can choose 2 out of those 12. And they told us there were 9 family movies. We're picking 3. So the way we would set this up is, out of the 12 comedies, we're picking 2. And out of the 9 family movies, we're picking 3. So we want this to happen and we want that to happen. Now we're just plugging those numbers into the equation. So 12 factorial, what goes in that first bottom blank? Yeah, 12 minus 2, I'm just going to write 10. But you could write 12 minus 2 if that helps you a little bit more. Times 2 factorial, right? And then in our second equation here, we have 9 factorial. That's our n in the second situation. And then we have 6 and 3, right? Following that, can I have someone tell me those 2 numbers that we have to multiply together? Does anyone have them? Yeah, Alex. Yeah. We have 66 options, 66 ways, 66 combinations for that first situation, and then we have to take into account how many ways that second situation can occur. So total, that is what? 5,544. That's a lot of options. All right, part B here. You can afford at most 2 movies. At most. So I could walk into the movie store and get 0 movies. I could walk into the movie store, get 1 movie. Or I could walk into the movie store and get 2 movies. But I can't get any more than that because it says that's all I can afford. I'm a college student. What can you do? How many movie combinations can you rent if this is the case? So we need to think about all these situations that could happen. But in this situation, only one of them is going to happen. That's why it's an or. You need to notice that we can rent 0, 1, or 2 movies. So this blank in part B's solution, because there are how many movies to choose from? 41. You're right. Gio, how did you get that? Yeah, they told us all the different movies that we have to choose from. So he just went up there and added all those numbers together to get the total amount of movies that we have when we're walking in the store. We have 41 movies to choose from. So the number of possible sets of movies is, we could pick 0 out of the 41, or we could pick just 1 out of the 41, or we could pick 2 out of the 41, right? You might want to take some time to type these 3 combinations into your calculator. Hopefully for that first one you get 1, the second one you get 41, and the third one you get 820. So the number of possible sets of movies, if you can rent 0, 1, or 2, is 862. Did you find yourself getting 1, 41, and 820? Hopefully, yeah? Are there any questions about part A or B? No? We're feeling good about it? All right, so what I'd like you to take some time to do right here is do this independent practice. Just 4 questions. The first 2 are just calculations, but remember, you need to write out the N and the R in the formula. And then 3 is a bit of an extension from that last example. And 4 is actually like kind of a reverse situation. We're given 6C3, and you have to come up with like a little bit of a story there. I mean, people wrote like 1 or 2 lines. Just what scenario would apply there if we are given 6C3? I've had people talk about pasta and shopping and all sorts of things. So get creative. We're good though? Alrighty. Alright, I'll put the answers up there. You might want to check how you did.